Hi, this is Randall Schwartz, host of FLOSS Weekly. This week, we're live. We're live at OSCON 2013. Simon Phipps is going to join me in a minute, and we're going to talk about OpenStack Swift, which is the file system that the OpenStack project is using. It's going to be real interesting, I'm sure. You're not going to want to miss this, so stay tuned.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for FLOSS Weekly is provided by CacheFly at CACHEFLY.com.
This is FLOSS Weekly with Randall Schwartz and Simon Phipps. Episode 258, recorded July 24th, 2013. OpenStack Swift. It's time for FLOSS Weekly, the show about free, libre, open source software. I'm your host, Randall Schwartz from MerlinDistonage.com, bringing you each week, or as often as I can get to it, the movers, the shakers, the big projects, small projects you probably use every day, probably you might not have ever heard of, and brand new projects as well, which is always the fun part here. You might notice a slight background, not only difference in the video if you're watching the video, but also in a little bit of more audio, because we're actually live at OSCON 2013. We're in the hallway. This is exciting, a lot of fun. To my immediate right is my co-host, that's Simon Phipps. Simon, welcome back to the show.
Good morning. Great to see you, Randall.
Very good, very good. I had to pull him away from breakfast. They give us complimentary breakfast here, and I had to pull him away and say, let's do the show. Let's do it. We're doing live. It's really great. Our project today is OpenStack Swift. I hope I'm pronouncing all that correctly. And Mr. John Dickinson, who is sitting to Simon's right, is going to talk to us about OpenStack Swift. Welcome to the show, John.
Good morning. Thanks for having me.
Thank you. And what's the 30,000-foot view of OpenStack Swift? What's the problem it's trying to solve?
It is a distributed object storage system designed to support massive scale, high availability, high durability, and massive concurrency across the entire data set. So conceptually, it's very similar to something like Amazon S3, except you can run it yourself and own your data.
Right. And when you say distributed, what do you mean? Do you mean distributed within the data center or distributed across the internet?
Yes, because it originally started out with focusing on being able to put your build a cluster within a single data center. Recently, we've added in the feature to support global clusters, which allows us to actually have globally distributed data storage.
Right. So is this kind of like Tahoe Labs, the sharded encrypted file system, or is it more like a clustering file system that happens to have an internet in the middle of it?
The point of Swift actually is that it is not a file system. It's one of the key characteristics there. So you don't have to worry about dealing with the POSIX layer to interact with the actual data itself. It uses a standard REST-based API. So it's just standard HTTP verbs and response codes, and it integrates very, very well with existing things out there that are used to dealing with web servers. So it is, okay, yeah.
No, so I'm fascinated by this because I've been studying Tahoe Labs, which is a free distributed file system. Right. Looks a very interesting system for creating genuinely distributed systems that don't have any there that can go that the NSA can monitor, for example. Right. Would Swift be the sort of solution somebody who wanted to put their data beyond the reach of the NSA would be able to use?
Absolutely. One thing that I really believe is a fundamental thing that we're trying to solve is that everybody has data, it's always growing, and you should have ownership of everything that touches your data, from the hardware all the way to the software to the tool chain that interacts with that. And that's only possible when you have open systems. And it's not just having access to the source code, but it's actually also being able to have ownership in the community and the governance of that. And it's one reason that I'm really excited about the OpenStack project in general, and Swift in particular, because anyone can get in and run the code themselves, but they can also lead the direction of the code. You don't have to worry about a single entity controlling it and blessing it to the rest of us by just throwing it over the wall. But rather, it's a massive community of companies and developers coming together to contribute this. And if you contribute something, a patch into Swift, it's going to be running at scale all over the world relatively soon.
Along that line, is Swift part of the OpenStack project, or is it its own project?
The OpenStack project is more of a grouping of individual sub-projects. So we're absolutely a part of the OpenStack project.
Right.
But the OpenStack project is has several sub-projects or programs inside of it. Some focused on compute and image management for your virtual machines, networking, block storage, and Swift solves the object storage piece for the OpenStack project. And so we are absolutely part of OpenStack, and we're managed through all of their infrastructure services, the governance in there, and that's how it works.
So it's not a separate committee then in charge of Swift, although you probably have some lead developers working on it.
We do. There's not a separate committee in charge of anything inside of OpenStack.
Okay.
But just like there are other OpenStack projects, we have a set of core reviewers and also a project technical lead. That person is me right now. But these people are coming from companies all over. Right now in Swift, we have 12 core developers from SwiftStack, which is where I work, Rackspace, Red Hat, and Innovance.
Right. So is Swift something that you can use without OpenStack?
Well, if you're using Swift, you are using part of OpenStack, right?
Yeah. But I was thinking more, so OpenStack has developed a reputation for being fiendishly complex and beyond the means of any normal mortal to actually deploy. Is Swift also in that category and requiring higher black arts to deploy it, or is it something that was within the means of? We have a lot of individual listeners on Floss Weekly. Could the viewers now actually install and use Swift in their home or in their small office?
I think they could. Being a distributed system and one that has a fair bit of knobs to turn and sharp, pointy operational bits, there are definitely, it does require a degree of experience to be able to effectively build and run a cluster. I know that's not the focus of your show, but that's actually what the company that I work for provides. It is possible, absolutely, to run Swift separate from other OpenStack components, and I've seen deployments that work alongside the other components inside of OpenStack, Nova and Cinder and Neutron, and also I've also seen quite a few people deploying Swift separate from that and simply saying, look, we have a storage problem. We need to figure out how to store data for our applications. And that's really what Swift is focused on, is storage for applications.
Right. Okay.
So somebody in the chat room actually said, I'm coding a app using Swift CDN.
Okay.
I guess that's the same thing.
I'm not sure. There
Maybe
are
something else called Swift.
There are several commercial providers, including Rackspace and HP, who have deployed Swift and have a CDN layer on top of it.
Okay.
And that's one of the advantages of Swift itself. It is able to be extended quite easily by deployers, so people like Rackspace and HP have added in CDN bindings using some open source code out there. People like SoftLayer have added on some metadata searching and things like that. But Swift itself is really focused on that core storage system. There's basically two hard problems. You've got to figure out how to store the data and distribute it throughout the cluster, and you've got to figure out how to handle failures, because failures will happen.
So it does the replication behind the scenes to make sure you have redundant copies of the data?
Yes, Swift is a replica-based system right now, and I'll add on to that in just a moment.
Okay.
So yes, it manages your replicas, and it places those effectively so that you can ensure that your replicas are stored in unique failure domains, so that if you lose a drive, a server, a rack, a data center, then you still have high availability and durability for your data, because it is spread throughout your entire infrastructure. Now, the interesting thing is something that we've started working on just in the last few weeks, is that SwiftStack, Intel, Box, and eVault are coming together with other people in the community to work on implementing the ability to do erasure codes within Swift, so that there's erasure codes are basically a way that you can take a piece of data, break it into different chunks, add in a little bit more, and store those chunks such that if you lose some of them, you can still reconstruct your data. The advantage of erasure codes is that you don't have to, you can still get very high durability while not having to store three full replicas of your data. It does have some trade-offs, though, in that it is more CPU intense, because you've got to do some calculations to store and recreate the data. And since you're dealing with many different locations that you're storing, instead of just looking at, I need to access one place and there's pull it off of a drive all at once. In certain circumstances, you may have a higher latency to get your data because you need to reconstruct something, or you may lose some availability if you have a split brain situation potentially in your cluster.
How smart does the client of the Swift setup need to be? Does it have to have a mapping of where data is, or is it only talking to the closest one and they all talk to each other and figure out?
That is a great question. The client does not need to be smart at all. And that, I think, is something that I've found talking to other systems is very different. The original design of Swift was to support the Rackspace Cloud Files project. That's where it was originally written before it was open sourced as part of OpenStack. And in that situation, the client is simply an HTTP client. There's no need for it to understand or really have any ability to talk to the back-end storage servers. Swift has a few component pieces. The first piece that implements all of those connections to the client is called the proxy server. Okay. And that is what coordinates all the discussions with the storage nodes in the background. Mm-hmm. And so it works around all of the failures. It implements the API so that when a request comes in, it's simply, here's a VIP, and talk to that. And then everything happens behind there. And the really great advantage of that is that then when you're doing application development and you distribute this application throughout the internet on mobile phones, on these very widely dispersed client devices, then all those clients can directly talk to the Swift cluster without having to be updated of the current status of your hardware uptime or something like that.
Can I have many of those endpoints all talking to the same cluster so I can run it in different zones or whatever?
Yes, you're probably, yes.
I asked a yes or no question. I try never to do that. So,
right.
So how does that work? Do they talk to each other to keep things in sync, or is there some sort of protocol down further to keep
So within the
sync?
cluster, there's obviously a lot of complicated deployment details you can get into there.
Yeah.
So within the cluster, the servers are talking to one another to ensure that you can get your data back and that the right data is in the right place, and there's lots of synchronization that can go on there. And so if you have these proxy servers and you can have them, a bunch of them load balanced in one location, or you could have, maybe you're using some sort of Anycast to have multiple locations or something like that. As long as it is part of the same logical Swift cluster, yes, there's communication between all those backend storage nodes.
And do you have the ability to say, go ahead and return back to me only when all the replicas are up to date, or maybe just write the first one at least, then return back to me? Okay, do you have selectability like that?
So on the reads, yes, we do.
Okay.
So the way that it works, and I'm not talking about the currently being developed erasure codes, but just looking at the replicated model right now that's available today. We have a quorum-based policy for returning success or failure to the client.
Okay.
So if you've got 3 replicas, we ensure we do not return success until it has been written successfully to at least 2 of those. And we'll do our best to absolutely make sure that things are correct in the system. Mm-hmm. But it's an eventually consistent system.
Right.
So that if one of those copies did not get successfully written, we can still return success to the client, and then asynchronously replicate that over to that 3rd location. On the same token, you can imagine that if you're overwriting data, putting new content for the same object name, then with this quorum eventually consistent model, it's possible to have some stale data depending on failure scenarios and things like that. So when in a normal circumstance, when you need to do a read for that data, it will choose one of those replicas and return that data as soon as it found something. Mm-hmm. There's also an option that the client could ask to say, no, absolutely do your best to give me the newest copy available. And in that case, you're going to sacrifice some latency because it's going to ask all of the backend copies and then compare them and say, okay, which one's the newest? Return that data instead of just the first available.
So you do have some knobs to adjust in the consistency, availability, durability spectrum.
Sure. And it's mostly along the lines of the consistency versus your latency. Yeah. And the general policy that is in failures, though, we're going to an eventually consistent system.
In terms of scaling up, can I throw more machines and more disks at my cluster, and does it automatically rebalance then, or do I have to do something manually about that?
There are Swift is designed so there is no single point of failure. There's no common metadata layer. There's not a giant database table holding mappings or anything like that. Things are done deterministically so that when a request comes in, we can hash that and place it appropriately in the cluster and determine where that's done. So if you need more storage space, great, you can add some more storage nodes. If you need some more capacity on your front-end throughput, you can add some more proxy servers. And you can scale those independently. You can deploy those independently if you'd like to. And it becomes a very modular system that allows you to grow to match your use case. Mm-hmm. And so I've seen clusters that relatively don't have a lot of data in them, but they have really high throughput needs. And so they have very large, high amounts of proxy servers compared to the hard drives, mm-hmm. As opposed to systems that are more focused on lots of cheap and deep storage, where they have massive amounts of hard drives behind a relatively few storage servers.
We have a question from the chat room. How does this compare to GlusterFS?
GlusterFS is designed to try to give you multiple views into that same data. And it's interesting that in the Swift community right now, Red Hat has been participating quite a bit. And the REST interface that Gluster is using actually is using Swift. So if you are able to use the Swift API, then you can access your Gluster storage volumes with that same API. And if you're using Gluster, you can talk to other Swift clusters as well without having to change your clients.
But this is using the REST API. Gluster also has the ability, I believe, to mount as an actual drive. I don't think
that is not part of Swift. And so the Swift is focused on saying we're going to solve object storage, and we're going to do that very well. We're not going to try to be the Swiss Army knife kind of storage system that can do everything for everybody. Kind of believe in the Unix philosophy of do one thing and do it well. I'm very happy that Red Hat is participating and promoting using the Swift APIs on top of Gluster, and they're definitely making the Swift code base better in their work.
Cool.
So if there's no file allocation table, I'm trying to get over the architecture here. Who is it that knows what object belongs to whom?
Right.
When I ask for an object, there has to be some authority that knows which of the many fragments that are all over the network constitute that object.
So I know that a few weeks ago you had Ceph on the show, and they talked about their crush algorithm. Mm-hmm. And that's a really cool algorithm. And it's similar the way that Swift does this, in that we have a consistent hashing ring that when the request comes in, the request name is hashed, and it is there's then this ring lookup table that says, okay, it hashed to value X. Value X should be living on storage nodes A, B, and C. So it goes out and does that. Now, as the storage capacity changes, then that mapping table is updated by an operator and deployed throughout the cluster. And but the advantage is that you can do that on a live system. You don't have to take the system down for adding capacity. You can gradually add capacity so that you don't saturate your network connections as things are moved throughout the cluster. And Swift does a really good job of keeping everything balanced across all of your storage nodes.
Right. So when I go to store an object, I get back a return receipt of some kind that I can then ask any proxy server to give me that, like a code check for my object.
Not quite, no. That is not the way it works. Let's say you have an account in Swift and you create a container called images and you store cat.jpg, because we know the internet is for storing cat pictures.
Yes. And replicating.
And so when you ask to put in your cat.jpg and you want to get that back later, you just ask again for cat.jpg. You're not given some object ID, some UUID or something like that. When you do a put request for the object, you're going to get back a 200 successful or 201 created.
So to find an object, I need to have my account ID and then the name of the container that I've put the thing into, and then the thing that I put into the container.
So the high-level namespace of Swift is that you're able to segment this into multiple Swift accounts. And these are really storage endpoints that are provisioned by your identity management system. So if you have an account on a Swift cluster, what you are generally given is a storage account on the Swift cluster. Inside of that, you can create as many containers as you want. These are kind of analogous to Amazon's S3 buckets. And you can create as many as you want, and they are uniquely named only to your account. So we can both have an images container. And then inside of that, you can put whatever objects you want. Containers aren't nested, but they simply keep a listing of all the objects inside of it.
Okay. Now, coming on to the structure of the actual cluster, one of the applications that I've been discussing with someone recently has been the idea of getting many users in a community to each chip in a little bit of their storage on their computer to form a distributed cloud. In Swift, is it possible to have storage servers that are shared between different clusters, or is it a straight hierarchical tree of this storage belongs to this Swift installation?
I suppose that could be possible. I don't know that anybody's done that or considered it. Swift is concerned about, at the lowest level, Swift is actually only concerned about a storage volume. And normally with, and the recommendations that we generally give out to people are that is a hard drive. Now, it's actually just a storage volume, just a mount points on a particular, behind a particular IP port. And so the understanding of the way that Swift works is generally there's going to be restricted access to those storage nodes and on that private network that they share. Because if you have direct access to the proxy server is what mediates who gets access to what and integrates with your auth system. So if you had direct access to these hard drives, you lose a lot of the protections you'd have in the multi-tenancy.
Right. And so this isn't the sort of thing that you would use for a distributed shared file system across the internet?
No, I don't think so. But also, again, Swift's not a file system.
Right. It just sounds remarkably like a file system, using different words to describe it.
It sounds more like a key value store, though, with really fat values.
Very big values, yes.
Yeah. What, with Ceph, every client that wanted to access anything in the cluster needed direct IP access to every node in the cluster. Is that true also with Swift?
That is not true with the Swift. All you need to know is the general storage endpoints that is your proxy server or the virtual IP for your load balanced proxy servers.
But the proxy server needs direct access to all nodes in the cluster. Okay, yes.
So what you can imagine is that if you have this deployed in a single data center, you may have several servers or several racks of servers that are just designated as storage nodes. This is where all your hard drives are. And then you may have a single proxy server in each of those racks behind a single load balancer, and then external clients just simply connect to those load balanced proxy servers.
Right. We had a question from the chat room just a moment ago. Is this simple enough to set up inside a single VM on a laptop to play with, or does it need a lot more hardware?
So that's a good question. All of the developers and contributors use a Swift all-in-one virtual machine. It kind of simulates a bunch of servers all running at once. And so, yes, I've got all-in-one virtual Swift machines running both on a cloud hosting provider and just on a VirtualBox on my laptop. Right. In reality, the smallest practical cluster that would actually provide you some good durability would be a single server with at least 3 hard drives, assuming you're using 3 replicas. But in where it becomes really practical, you're probably going to start looking at a server or two that have several. Let's start at about a dozen terabytes or so, and then go up from there.
Well, we get a lot of people who say to us, if I can't apt-get Swift, then it's no use. And so can I apt-get Swift?
Sure, and that's one of the great things is being part of the OpenStack project. Is there's a lot of work with the distribution, the distros, specifically with Red Hat and Canonical in Ubuntu and RHEL and CentOS. So one of the things is that they generally package up those 6-month OpenStack releases. Swift releases production-ready releases more often than that, generally about every 6 to 8 to 10 weeks. And those then can be packaged up if you want to. there are other people who have published some Debian packages if you wanted to take a look at those.
What's the management interface? Is there a GUI? Is there a command line API? Maybe both?
So as far as management interfaces, Swift provides a lot of hooks for that sort of thing, but doesn't really provide a strong management interface for that, because from Swift's perspective, the pieces that you can manage are config files and updating your ring, and there are config files are just text files, so you can edit that however you want. Some of the other things like the updating the ring, there are command line utilities for that. And then there are other people who've come along like SwiftStack to provide a more elegant and smooth management experience.
Can I do a graceful removal of a machine
Absolutely.
From a cluster?
Absolutely. You can both graceful additions and removals. Okay. Even if it's a very large amount of data, say you had several dozen hard drives on a JBOD on a single node, you can pull that out. We have a concept of a wait, so you can gradually drain or fill up a drive gracefully. And you don't have to worry about saturating your network switches by saying, oh, by the way, here's another 96 terabytes, boom.
Yeah. That's great for management then to be able to pull that in.
Yeah.
Yeah.
Swift has been running in production for over 3 years at Rackspace and at a lot of other places for nearly that long. And those are some of those challenges that you see all the time as those clusters grow and as you have unexpected capacity adjustments like failures. And that's just one of it's par for the course. You have to handle that.
Does it handle automatic removal of a machine if it doesn't show up for, say, 96 hours?
Not quite. So not quite in that way.
Okay.
So what happens is that if a hard drive fails, then Swift will automatically work around that, and any data that was on that drive will be replicated throughout the rest of the system so that you still maintain your durability for those most common failure scenarios. However, if you have a single server down, normally that's not a durability issue. It's probably a network connection or a power supply or something like that, but it's probably not that all 24 hard drives just suddenly you're not working.
And the CPU.
Yeah. So what Swift treats that as an availability issue and doesn't try to automatically replicate that stuff, which is really important when you think about something that may be an intermittent failure. Yeah. And so in that situation, that is something that Swift provides some alerting on, and you can certainly detect that within the cluster. But that would require an operator to come in and either mark it as resolved or remove it from the ring data structure so that the system continues to work around it.
And are you able to get some sort of like Nagios alert on that then, and so someone can detect that?
And the way that Swift works, or as part of Swift's core, there's an extremely deep integration with StatsD metrics.
Okay.
So it sends out these metrics for just about everything, and it can be very easily integrated into systems like Nagios and Ganglia and other stuff.
One of the problems you have when you have storage that's detached from its user is garbage collection.
Right.
When accounts disappear.
Right.
How do you manage that in a distributed cluster like that?
We have some processes that run automatically on the storage nodes that check for is this container, is this account gone? Has it been deleted? And if so, it will automatically reap that slowly in the background. And by the same token, we also have a feature in Swift to support expiring objects, so that if you have an object that you say, I need to make sure this is deleted after 30 days, or maybe you have a 7-year data retention policy or something like that, this cluster will automatically make sure it's unavailable at that time, and then in the background delete it as it can.
So now we ought to ask about your community.
Sure.
So who is involved in making this software exist?
Sure. So in our last release, which was Swift 1.9, we had a total of 120 contributors to the project, aggregate across the life cycle of the project. It's been growing extremely rapidly. And if you think about just 3 years ago, it was basically about 7 to 10 developers at Rackspace, and growing all the way to 120 in just 3 years is pretty important. The top contributors that I'd like to call out as far as making valuable contributions, especially recently, are Red Hat, IBM, Rackspace, of course, is still involved, SwiftStack is pushing forward a lot of the new development.
Right. So those are large corporations, typically. Do you have smaller contributors as well from individual consultancies or individual deployers?
We have quite a few. Like I said, we had quite a few, several dozen companies. Probably, it's hard to say, but there's at least 43 unique domain names in the contributors file. Of course, the biggest of those is Gmail.
Right.
So
they contribute a lot to a lot of systems, I've noticed.
And so I do not know anyone who contributes to Swift that is not paid to do so. Which is actually rather interesting, and I think is a characteristic that is quite common in all of the OpenStack projects.
Yes.
It is certainly available for people to come by and say, I want to do some one-off contributions to this open source project, and we certainly welcome that and are happy to accept those. But most of the people who are looking at it are people who are looking at it because their company is actually looking at it and deploying it and using it in production. So they have a vested interest to make sure that their bugs are patched, their features are added, and that's how the community's been moving forward.
So how did you get to be in the seat with the orb and the scepter?
Wow, I certainly. Much more power than I actually have. I would say I was in the right place at the right time, or the wrong place at the right time, depending on your perspective. So I was on the team at Rackspace, on that Cloud Files team that originally developed Swift. And as it was open sourced, the people were looking for volunteers to go stand up in front of people and talk about the project. And I was one of the few people who was interested in doing that on that team. And as that happened, the governance of OpenStack established these other positions, and so I let the project technical leads and the technical committees and things like that. And so I think I was the person who enjoyed the upsides enough to put up with the downsides more than the other people. So it's something I'm really excited to do. I'm really proud to do, and grateful that the community's elected me to do it.
So and how does that work? Is this a job for life? Are you going to retire in this job, or is the community re-electing you annually, or is it based on highest number of commits that get the most votes?
Not at all.
How does it work?
Anyone who contributes into the project in any OpenStack project is granted active technical contributor status for, I think, 1 year. If you are an active technical contributor into an OpenStack project, you have voting rights. And that allows you to elect members to the foundation, to the technical committee, and also to the project technical lead for that particular project you've contributed to. And so every 6 months, the project technical lead position is up for election. And if you've contributed into the project, you can run for election and
so you have to keep contributing to make sure you can vote.
Right. At least once a year,
Yeah, okay.
which I think I'm good at.
There you go. Earlier you were talking about, we keep sort of dancing around the fact that this is somewhat like S3 and that you're storing a chunk of data at a given address. Is the protocol compatible with S3? Or if not, how hard is it to migrate my app from S3 to this?
From the basic functionality, it's extremely similar.
Okay.
The biggest differences on the surface have to do with the authentication mechanisms that Amazon has for their products versus the way that Swift deployers have for theirs. I think the fundamental difference is that S3 is a product and Swift is a storage engine on top of which you can build a product.
Okay.
But the APIs aren't directly compatible, but there is a community-supported adaptive layer that you can that implements more of the S3 API for Swift. And so you can use S3 tools to talk to a Swift cluster if it's running this Swift 3 API layer. We're really focused on making sure that we can not be at best, a fast follower as far as APIs go. And so our API has been extremely stable. We've had the same API that we've added to, but not broken in any backwards incompatible ways for the past 4 years. And so that's kind of how we have worked in that environment.
Yes. That's nothing to do with being worried that Amazon hasn't released the specs for S3 under an open license.
I think that is part of it. But as There's been some discussion recently within the OpenStack community about this topic, and I think one of the points that was brought up is that a simple API compatibility is not actually what is. It's not the complete picture, because you have to talk about what are the concepts behind that and what are the general performance characteristics that you're dealing with there. I mean, if you put an S3 interface on top of dev null, you don't get what you expect, even if it has the same API.
But dev null can shard.
And
It's web scale.
It's web scale, yeah.
And that does give you, the ability to store any file you want in dev null,
Right, that's true.
without having to do any new programming.
That's true.
Write once, read never.
But the point on that is that as you go into some more complicated features that allow you to do a lot of that application heavy lifting for storage, for example, the static website hosting, large object supports, expiring objects, versioned writes, all of these sort of things, being able to have control over our API and have that as something that anybody can contribute to does give you that openness, which gives you ownership of the system, but it also allows you to innovate in your own ways without having to be a fast follower and ensure that you are that you are subject to the whims of a press release of some corporation.
Yeah, so I've listened to a little bit of this conversation, and it all
Sure.
seems to me to be rationalizing a fear of Amazon. It seems to me that everyone who's going to deploy OpenStack is probably going to have to implement some way of at least importing data from S3, because that's where, if they're providing any kind of a public service, that's where all the data is
Sure.
already. So aren't you just ensuring that every single contributor to Swift is going to have to privately implement an S3 API that will sit on top of Swift?
No, I don't think so. And that's not what I've seen in the deployments that I've been a part of, both looking at Rackspace and also all of our customers at SwiftStack. There are certainly people who are migrating off of S3, and that is certainly a concern for some customers. But I think that in a large part, there is such an opportunity as far as a massively growing market that the people who are looking at Swift as an alternative to S3 are just one small part of that overall market opportunity. You've got people coming off of traditional storage vendors that like EMC, NetApp, and things like that, where they're just looking at it and saying, we need something cheaper, we need something that fits our application use case patterns much more effectively. And they're not concerned about, well, did I choose the right API? What they're concerned about is making sure that they have something that delivers a very good value for the cost. And that's something that a Swift deployment can do, because it can be deployed on commodity hardware, and there's no licensing costs and things like that. There are, now as a developer and from a developer background, I think that some of that is, I can understand where the business value of having common APIs comes in, but really when it comes down to it, if I'm writing the next photo sharing app or whatnot, the hard part is not figuring out what is the API I'm using to store a particular image. The hard part is all of the other things around that.
Yeah.
The API question there, from my perspective, coming from a developer background, is, okay, just tell me what the API is and I will use it. And so, I certainly don't want to exclude people and a tool ecosystem that is out there. And there are some, like I said, there's the Swift 3 compatibility layer that is especially good for some migration workloads. But I think moving forward, being able to see people who are having new data sets that are growing into needing something like Swift, people who are moving off of existing traditional storage vendors, really outweigh, or really give us a strong weight to say this is where we're going, and we've got a really stable, great system for them.
Obviously, Red Hat was using this internally. No, Rackspace was using this internally to do their storage, and
Right.
the product was obviously production ready at that point.
Right.
But you've added probably a lot of code since
Quite a
then.
bit.
Do you consider the code still industrial strength ready?
Absolutely,
Okay.
without a doubt.
What about community and commercial support?
Sure. The community support, I suppose, is come in IRC and ask questions on the mailing list and things like that, just the traditional open source project methods. There are some companies out there who can offer some consulting services. They also just do some other general OpenStack consulting services. As far as other commercial support, the company I work for, SwiftStack, definitely provides a product that allows a lot of smooths over all that management pieces. Works a lot on the integration, the monitoring, and the management of running Swift clusters, and gives a nice UI for that. We'll definitely work with our customers to ensure that you have a successful storage solution.
And so who defines the roadmap? Is that just the core developers?
The roadmap is really there is no, this is the roadmap and this is what we're going to do. Okay. Because I have as much control as PTL of Swift over the developers in the community as I have over asking you to do something, which is, if you want to do it, you'll do it. And if you don't, you don't. The role of the community guidance there is let's as a community come together, solve the pain points that we have, and if, for example, Rackspace has a particular pain point, they're going to contribute developer time to solve that. If SwiftStack is working on a particular new feature for customers, for example, erasure codes, then we're going to work on that, and that's kind of how the community has moved forward in saying, okay, here's the real pain points we see, here's the features we need to address, and then people who are participating in that are working towards that. So as things that are coming up, there are currently people working on some exciting features as far as Red Hat interfacing or cleaning some things up within the code base to make a really nice interface to Gluster. SwiftStack and others that I mentioned are working on erasure codes. We've got people who are working on really focusing on some performance issues. And I'm sure there's going to be quite a few other exciting things coming.
We're almost out of time. We have time pressed today because we have an announcement coming up in a few minutes on the live channel. Is there anything we didn't ask that you want to make sure our audience is aware of?
I think the overall thing that is important for me to say about Swift, especially in comparison with some other storage systems out there, is that Swift is designed to be application for storage. And so it is absolutely perfect when you have a ton of user data that needs to be highly available across the entire data set. And it is designed for scale, optimized for durability, availability, concurrency. Concurrency is really kind of that major thing there. We're not trying to go after Swift is not designed to be this block storage system that is going to underline your virtual machines. Instead, we're going to actually solve the problems and offload that heavy lifting that applications need to do, that are the applications that people have been writing for web scale, for the internet, and those new things that are coming up.
And also, I'm curious, can you update and read single blocks or partial ranges of blocks from within an object?
You cannot overwrite, you cannot do partial overwrites of objects, but you can absolutely use standard HTTP range requests to get out subsets of it.
Okay.
And you can even do multiple range requests in a single thing. So we support just about all RFC 2616 is pretty much our Bible for how does this work.
Simon, any last questions?
No, I'm pretty much done with this. I'm going to go and do some comparisons in function between the different file systems I'm looking at.
Look forward to it.
So I've got to ask the two final questions of every show, which is favorite text editor.
I use Sublime Text.
Okay,
Sorry.
One for the other column, right? and I bet I know what the favorite scripting language is. Go ahead.
Of course, it's Python.
I can't get a win on any of those.
Sorry.
Oh, man.
Good job on between the two of you.
Fight, so, yes.
If you have any questions, we are on Freenode on OpenStack-Swift. We've got the OpenStack mailing list, and you can find a lot of documentation at swift.openstack.org.
As usual, our URLs will be in the show notes. If you go to the twit.tv/floss page, you'll be able to see all that as well. Well, John, thank you for being on the show.
Thank you for your time.
Right, and
my pleasure.
Thank you. And so you're just going to sit quietly over here while Simon and I chat for a bit.
Okay.
So what do you think?
Well, it's an interesting system. Any file storage system is going to be complex.
Yeah, a lot of moving parts.
There's a lot of moving parts in there, and I'm quite interested to see if it's possible to play with it. I've tried to reach into OpenStack and play with that, and it's impossible. It's just got so many moving parts, and it takes so much history to be able to even work out how to get it out of the box, let alone to put it into your box. And it sounds like this might be something I can use from OpenStack to actually do some tasks. So I'll be interested to have a play with it.
Cool. Well, I don't have anything to add to that. So let's quickly wrap up the show because, again, we're booked on time here. So we have coming up next week, we have, so we're at OSCON this week. It's OSCON 2013. I'm live in Portland, Oregon. That's why you hear a lot of noise behind you if you didn't listen at the beginning of the show. Next week, we have a number of we have a number of interviews, little 5-10 minute interviews that we're doing this week. We're going to put those together I'm just going to call it the clip show for next week. So Simon's been really great running around. Can I announce that special one?
Well, I've got a couple of them. So I did talk with Mark Shuttleworth yesterday about his new Edge phone, and I hope to have Jeff Hawkins later on today, who's one of the keynotes today. Awesome. And I'm out stalking anyone that will sit at the table in the cafe with me and do a 5-minute interview with me.
Awesome. So we have some really great. I hope you took notes about who each person's name is, right?
I think I can remember who they all are.
Okay, great. I was going to go, how are we going to tag each of these unless it works that way? Okay, so that's next week. The week after, we've got OpsView, which is an enterprise server monitor. We've got, following that, Kaltura, which is the video production system. We've got Clockwork, which is a language and tools for process control. I don't know any more about it than that. Sorry, it's those 7 words. That's all I know. And we also have a guest that's been on previously. We got Thomas Hatch coming back. He's in charge of the Salt Stack project. The Salt is a not distributed, but a kind of like the same space as Chef and Puppet in that it maintains systems, that brings them up to date. But there's some new works in the works. That doesn't even make sense. New things in the works to make it more cloudy. So bare metal deployment, all sorts of wonderful things. So we're going to bring him back on to talk about that as well. Still filling a few more slots on Q3. Got a couple more to do, so I'm still sending out my emails to find out who is coming up. You can also go to twit.tv/floss. That's our homepage for that. And there's a big spreadsheet listed from there that tells you all the upcoming guests. We also, if you want to find out when I actually add a guest, you can follow us on Floss Weekly on Google+. I announce them there all the time. I will then forward that over to my personal Google+ as well. That's Randall L. Schwartz. We also have what is that? Twitter handle. Oh man, it's too early in the morning. A Twitter handle of at Floss Weekly for that sort of stuff. I think I'll just quit here now. Okay, we do have a live chat. We took a couple of questions from the chat room this morning. It's on live.twit.tv. We're normally on at 8:30 a.m. Pacific time. We started a half hour early because we had up against a hard deadline in a few minutes. You can follow me, of course, at Merlin, MERLYN on Twitter. And you can also follow me on Google+, Randall L. Schwartz. I'll be back in Southern California for the next few weeks following this week. I'm really happy to be home in my own place in Portland. I've been here actually for like 8 days, which is really bizarre for me to be here 8 days. That's about all I want to plug, so watch for me there. Simon, do you want to plug some stuff?
I'm still writing in InfoWorld every Friday. I'd love to hear your comments on the columns that I'm writing there. You'll find me on webmink.com. Which is where everything gets aggregated for me. Webmink.
Yeah,
Webmink.
It must be early.
Yes. You needed more coffee this morning. And coming up, I've got a few shows. I'm helping to organize a track at Open World Forum in Paris in October. And I hope that a lot of the folk in Europe who listened and watched the show will be coming over to Open World Forum. If you really want to track everything I do, follow me on Twitter, where I am Webmink.
There we go. Not Webamink. There's no A in there.
No A in them.
Also, later today, I'm doing a talk called My Half-Life with Perl. And I think I'm going to be able to video and record my screen. So I don't think they're going to capture it normally, but I'm going to do it myself. It's basically about the fact that Perl's 25 years old, and I'm 51 years old now. So I've spent half my life with Perl and had a lot to contribute to a lot of the key events in the Perl community. So, but in return, Perl's also contributed a lot to my life. So I've got, I think, the 35 best anecdotes. So I've got about 40 minutes, so it's going to be a quick show. But I'm going to see if I can slide that into some online production from that. So I'm going to put it up in Vimeo or something. So I'll announce that in this show, and of course watch my Google+. I'm sure I'm going to talk about it there. I think that's all I've got to say. So thanks again to John Dickinson. Thank you.
Thank you.
Yeah, for coming on to our show today, and we'll see you all again next time on Floss Weekly.